Welcome back. In this video, while I'm waiting on putting together a tooling order, I'm revisiting some of the previous cuts to see if I can make them better. So here I just pacing off the surface again, and this time I'm using a bit more of an aggressive cut, and it works fine. And then I'm also going to play around with the drilling operation a little bit. I thought maybe I could speed it up. So here what I'm doing is I increased the feed rate just a little bit. It was 1.7 inches a minute, now it's 2. And instead of doing a full retract peck, I'm just doing a brake chip, like a 1/10 of an inch brake chip peck. And it works great initially, but as you can see, there's smoke coming out of the bottom of this thing, so it's really built up some heat. So I don't think I'm going to keep that. I think I'm just going to go with the full retract peck. So I come in here using some much more aggressive parameters suggested by Carl from Lakeshorecarbide. This is his end mill, and I'm doing a 800 thousandths depth of cut, and this is just kind of spiraling out to roughly I believe it was 4 thousandths undersized on the bore. And I guess I have to double check the code, but maybe that thing is wobbling in the vise again. There just must be a tremendous amount of radial load put on that part. But anyway, it's chattery and I don't like the sound of it. So I'm going to definitely figure out a better way for that. So here's essentially the same parameters, maybe a bit more aggressive. 800 thousandths depth of cut, 70 thousandths width of cut, just spiraling out the bulk of the material. And as you can see, the RPM reading up there in the left corner of your screen, I'm playing with the spindle override, just trying to adjust the RPM to see if I can minimize the chatter. So I initially wanted to start this out at 2125 RPM, which is what I was doing before, and Carl suggested I slow it down a bit. So I started out at 1900, mainly because I accidentally had the spindle speed override already at 10%. But it's still a bit chattery, so 2125 would certainly be more chattery than this. And I actually reset the override later in this program, and just for a moment you can hear how bad it sounds. So I let it go at this RPM for a while just because it didn't sound terrible. Then I bumped it down to 1700 RPM with the override. And I think that sounded a lot better. I didn't want to go too low because the lower you go with the RPM while keeping the feed rate the same, you increase the chip load and also the deflection on the end mill. So I wanted to go low enough to where the chatter just disappears. And then here I reset it, and you can hear how bad that sounds. And then I bump it back down to 1900, and then I bump it back down to 1700 again. So once I establish a pretty good chip load here, I might in the future increase the RPM and proportionally increase the feed rate so I can maintain that good chip load and just see if the chatter is still an issue. But for right now, it's okay. So here's the main profile roughing operation. It's the same parameters, but I start out at 1900 RPM. And this obviously has a variable width of cut, but I believe the deepest I measured is about 1/8 of an inch. Still a little bit chattery, especially in those internal radiuses. Then I bump it down to 1700 and see how that sounds. I think it sounds better. Still a little chirpy here and there, but much better overall. So I've gone from doing the roughing pass in maybe 100 Z levels down to 3. So next I wanted to try finishing it with a much deeper depth cut and just taking that RPM really low. See if I can get a nice finish. I'm doing this in 2 passes just because the flute length is only 2 inches and the total depth I need to go is just over 2 inches. Ideally I'd like to get it in 1 pass, but I don't think that's going to happen with this end mill. Carl also suggested something that he carries called a long reach end mill, which I might use in the future, but right now I'm just using what I have. So I started out at 1430 RPM. I bumped it down to 1100. This is a 2/1000th width of cut. And it seems okay, but there's some marks on the part there where you can see it didn't quite go deep enough. So I think a deeper width would probably work out better. Okay, so I'm doing a 5/1000th width of cut this time. Bumped up the RPM a little bit to 1200 and I'll adjust it from there. It's a little chattery, so I go ahead and I'm just hitting the override button downwards until it sounds okay, and I ended up stopping at 960 right there. That's a pretty good chip load. The RPM is much lower than I expected it should be to get rid of that chatter. The numbers from GWizard they were around, for this cut I believe they're around 2125, which seems too fast now. So I'm going back and trying it at 950 RPM with the 2000s with the cut. I'm just trying to determine if a larger width of cut is better or produces a better finish. Like maybe it stabilizes the cutter better. Maybe the flutes are taking more of a uniform bite, increasing or improving the surface finish. I didn't really notice a huge difference. It seemed like maybe the larger the width of cut, maybe it was slightly better surface, but it was probably just too close to tell. So that works out pretty good. It leaves a really nice finish to the touch. So I'm trying it again. I lowered the RPM even further to 900, and I'm trying a 6,000th width of cut. This is the final pass here. And that seemed to be just fine. Like, I didn't really notice that big of a difference between the finishes. Maybe I should be going even deeper. I'm not sure. Maybe 10 thousandths or 15 thousandths would be better. But this left a nice finish. There's really no evidence that this was done in 2 passes. Like there's no lip or anything between the 2 cuts. I guess ideally I'd have a 2 1/4 inch flute end mill so I could do it all in 1 pass. But they don't make those as far as I can tell. So that worked out pretty good. Now I also wanted to redo these operations here on the bayonet lug. If you recall before is when I snapped that 1/2 inch end mill. And that end mill was all beaten to hell, and it was also really dull and had chipped edges, so that's certainly why I broke this 3/8 inch roughing and mill cuts so much better, and I can do it all in one pass instead of multiple passes. So that is awesome. I do that in 2 passes. I could probably do it in 1, but 2 passes is okay. And then I come in and I just do a finishing pass just on the floor. 5,000 finishing pass just to clean up that floor. And that sounded great. Next I go through and I cut those recesses out with this 3/16 inch end mill, and I do it all in 1 pass instead of 4 like I did the first time. That worked out great. In fact, I might get rid of this finish pass just because it seems that the finish was better on the roughing pass than it was on the finishing pass. And that was a finishing pass just to clean up the bottom of that bayonet lug and get rid of the chamfer that's in the corner. So some of these cuts sound so good, I'm wondering if I can get rid of the finishing pass. So that time I think I can, just because the finishing pass just seemed to make the surface worse than the roughing pass did. So I tried to do that on these cuts too. If you recall, these worked out great before. So I thought, well, maybe I can get rid of the finishing pass. So I tried to do it all in 1 pass. And while it is certainly a fine enough finish for sandblasting, I don't like, mainly right here, it kind of chatters a little bit and you can see it. Definitely with the finish pass, the surface is much better on these operations. That goes for this chamfering operation plus this roundover. And one thing I noticed was that this roundover, doing it in 1 pass, leaves a bit of a ledge, which you'll see in the photos later. A ledge on the side, and the reason being, I believe, is because those finishing passes that I took before with the long end mill that I did around the profile didn't quite go deep enough, and it's probably due to deflection. But it could be because I just misprogrammed the final depth pass because I was kind of doing it, calculating how much needed to come off to get to the model. But I'll try to figure that out. But overall, the finish looks really nice. It feels very smooth. It's not wavy and chattery. So, and the best part is it took no time at all. So I think I'm going to keep that and maybe modify it a little bit more in the future. But pretty happy with how that turned out. Thanks for watching. Please visit my website and stay tuned for the next video.